This last presentation is not my presentation. Normally Keon would give it, but Keon said, you know, he was tired of you all, and you know, yeah, so I'm going to do it. Again, I know most of the stuff here, but you know, I would say if this is not the most smooth presentation, I mean, but just ask questions, okay? Just ask questions. I'll give you good answers, okay? Okay. Oh, by the way, there's and Keon is really good at speaker notes, right? So there are speaker notes here. Probably things I'm going to forget to mention, or I might actually even look back at it depending on the situation, right? But definitely look at his speaker notes. He has a bunch of the like stuff in here, and it'll give you more insight into his approach of giving this presentation. Okay. Okay. So pallet hooks. We had talked at the very, very beginning introduction of Frame that we provide access to some hooks. The ones that I described to you were like on initialize, on finalize, which is the stuff at the beginning of the block, stuff at the end of the block. And by the way, hooks are something that is unique to runtime, pallets, and Frame in general, right? In a smart contract, you can't really have a hook. Again, a smart contract, every single action needs to be initiated by a contract call, by a call to the contract from an outside party, right? With hooks, you can actually integrate logic of your runtime into the normal block creation process, right? So as blocks are being created, your runtime is getting called and hooks are being implemented that you can actually access, right? This is a very powerful tool you can use. So on-chain, here are some of the hooks. On runtime upgrade, something that happens when an upgrade is going to happen. On initialize, pull, this is a work in progress. On finalize, on idle. And then off-chain, we also have hooks. Genesis build, so this is something that is a hook that happens on the very first block of your blockchain. Off-chain workers, integrity tests, this is something that happens during compile time to verify that any tests that you want to make sure that happen in the runtime composition is happening. I'll explain that a little bit more. And then tri-state, I think this is a special hook that you can like run migrations locally before they actually run. But these are all kind of hooks that you can access inside of your pallet. And we're going to go over all of them. Most of them. I don't know, we'll see. Okay, and then if you actually look in the code base, you can see all of these things here, right? So there's actually this trait, hooks. And the trait hooks includes all these functions. And oftentimes, you actually don't see this in pallets, right? But it's being put in there for you. So if you do not define the hooks, a null implementation of this is being put in there. Actually, that's why not? Look, let's go real quick. I believe this is true. If I do cargo expand pallet dex, and I think, oh, so, okay, whatever. I think you all know that pallet dex has no hooks in it, right? Let it think. Why is it checking? I guess it needs to check in order to build it. Okay, it's done. So this should be pallet dex, and in here there should be hooks. There we go. Hooks, hooks, hooks. So you can see that we are adding for you the hooks that do nothing, right? So imagine like the default state is a hook that you don't use the hook, right? So if you add the hook to your pallet, then we use it. If you don't add the hook, we put a default one in there and we don't use it. But obviously every pallet needs to have a hook to be compliant with like the what's the word I'm looking for? Like everything has to be homogeneous, right? In the APIs, right? Okay. So this is what the hooks look like in the background, and of course Genesis build. Okay. So on runtime upgrade, the first hook. This is called every time the spec version or spec name is bumped. So when you upgrade and you make a new WASM, you control the spec version, and the spec version is basically telling the code what the new version is. So if you increment it, it's a new WASM, right? And you can use this to be able to call things when the runtime is going to be upgraded. So Keon asked the question, why might you be interested in implementing this? Give me some ideas what you would do with this.
What?
Why might you want a hook during a runtime upgrade? Why don't we move the mic over? Yeah, give the opportunity. Yeah.
Maybe like data migration.
Data migration. That's a perfect example. Yep. Data migration, or even data initialization. Maybe you have a blockchain that's already running for a while. You add a new pallet, but you need to initialize it, right? So these are both great use cases for why you might do the on runtime hook. And you see that most runtime upgrades, where there's a breaking change to the to the runtime will include an on-runtime hook, which is a migration. In the case of a fork, you have to be more explicit.
That probably is related to the when the data changes. I mean, you don't want inconsistencies with your block.
Right. So, but what kind of fork? Is this a fork because consensus had a problem, or is this a fork because someone wants to fork your chain to make a new chain? Like what? Like
because you updated the runtime.
So I believe we told you that Substrate is a forkless runtime environment, that we provide forkless upgrades. And the reason we do that is because the runtime, the state transition function, is part of the storage of your blockchain. So if you're running a Substrate chain and we make an upgrade, everyone who's running the blockchain gets the same upgrade. So there should never be a fork because of a migration. Okay? Okay. Now there's a hook for onInitialize. This is a useful hook for any kind of automatic operation. The onInitialize hook, if we go back to here, returns a weight. And that weight is the weight of the logic being run by onInitialize, right? And this dispatch class is mandatory. So basically, onInitialize must complete successfully every block. If you write code in onInitialize, the block is not valid unless that onInitialize completely executes. So if you panic in the onInitialize, you have bricked your chain. It will never get past the onInitialize step. OnFinalize. This is basically an extension of onInitialize, but it happens at the end of the block. So you onInitialize at the beginning of the block, you do some logic. OnFinalize at the end of the block, you do some logic. Now it's interesting. Look at this. OnInitialize returns a weight. OnFinalize does not. Why is that? You want to pass the mic over here? Why is that?
So, beginning in the block, when you do some logic, you want to track how much weight you're using so that other extrinsic can, like the block has finite size, right? So after consuming, you have to make sure, like put some logic which cannot consume much logic, much weight, and which allow other extrinsic to execute. But also like the final hook, the onFinalize, it doesn't require because it only uses the remaining weight from the block. So
actually, you're almost on the right track. What you're describing is actually on idle. But onFinalize it doesn't work that way.
Okay.
OnFinalize, so we can say in this code here, or in this text, the OnFinalize is a extension of onInitialize. The weight of OnFinalize must be included in the weight of onInitialize, or must be included in the weight of the individual extrinsics, which may trigger more logic. Let me say this one more time. Let me give you a more concrete example, okay? Imagine at the beginning of the block, I'm going to store some number, and at the end of the block, I'm going to delete that number, just so that it doesn't get into the permanent storage, right? So I have some logic that's working together. OnInitialize, I add a number. OnFinalize, I delete the number. I need to, in the OnInitialize, account for the weight of adding and deleting the number, so I can take account at the beginning of the block, the work that will be done at the end of the block. Right? I need to take into account when I add transactions to my blockchain that there will be some extra weight needed for this removal. So they're working together. Similarly, imagine this. This is a property of HydraDX. This is one of the exchanges in Polkadot. I believe one of the ways they try to solve MEV attacks, this is the minor extractable value, or whatever the term is, maximally extractable value, is that instead of executing DEX exchanges as soon as they come in, all DEX exchanges are queued to the end of the block and then all executed at one time. So this stops sandwich attacks, and this stops other kinds of manipulation of the thing. So if someone sees the transaction coming in, which will increase the price of a token, they can't, shove another transaction in earlier to stop it. All the trades are happening on even level at the end of the block. So in this context, each extrinsic not only has to take into account the weight of that extrinsic, but also the weight of the additional computation it will trigger on OnFinalize. Basically, we cannot overflow a block. We cannot put too much weight into a block, or we cause our block time to be too long. This will call our blocks to stall. And if you're a pair chain, it will mean the relay chain will reject your blocks. If this doesn't exactly make sense, this is all about benchmarking and weights. We'll have a talk on that, okay?
So just add on. So Shawn, you mean on initialize, it will also calculate the on finalized weight. On initialize.
Yes, on initialize or in the individual extrinsics.
Yeah.
Basically, on finalize does not give you a weight return.
Yes.
You must have already accounted for it, because on finalize must execute.
Yes.
It just has to execute. It can't report to me after the fact. Oh, I used this much weight. I'm sorry.
So,
It's gonna run. So we don't even allow that API. You must account for it ahead of time, or you've made a dangerous blockchain.
oh, so it means like a futures weight. Like it means like this weight will be used by some function which I'm
Exactly.
accounting it for now.
Exactly. So on and finalize returning a weight doesn't make sense because it needs to have already been accounted for. We have to predict the weight of on finalize. It's not. Yeah. Well, this won't compile because this doesn't satisfy the trait. The trait is this. The trait is this. So it doesn't have it. But I think what Kian is saying here is that it doesn't make sense for on finalize to return a weight because we can't do anything. The whole point about it returning a weight is so that we can predict how much to fill the block. Once you get to on finalize, it's already too late. Like if it's too big, like sorry guys, like it's already done. A question in the back. Can we get the microphone in the back?
Don't we already check all the calls that's going to be called and check all the weights beforehand, or like how? Because we can still have a weight, but calculated at the beginning, right? Because
yes,
we
know,
know,
initialize.
because we know that the on-finalize will be called, so we
Yes.
can have it return a weight and check this weight
No.
at the beginning. That's what I mean. You get what I
No,
mean?
so in this context, the way we designed it is that you put that weight in the on initialize.
I'm asking. I mean, it's not clear to me the design, like decision here, because we can add a weight. Everything is possible, but I mean, like adding a weight and accounting for it from the beginning, I can like reason about it more than just having no weight and remembering that I need to account for this weight. You get what I mean?
I kind of hear you here. I guess it's an opinion. It's a design decision, but I think the main idea here is that we're doing it because if you're returning a weight from on finalize, you might be thinking, oh, I'm trying to tell the blockchain how much I'm using. It's already too late. It's already been executed. The blockchain cannot learn anything from your weight. And by the way, I think the one more thing I'm saying is, I think you're describing, could I have an API on finalized weight, and it only returns the weight? This function isn't just returning the weight, it's actually executing code. So I can't just call it execute code and then get the weight. You can make a function which is the on finalized weight, which is what we do. Yeah, okay.
What about the situation when on finalize code depends on what happened in the extrinsics?
Exactly, so each extrinsic should include an additional weight, taking into account how much extra computation will happen on finalize. So if we're imagine this. Imagine that I have an extrinsic which adds a number to the storage. And the on finalize, its job is to remove all the numbers. So every time I do an extrinsic which adds a number, I need to also have the weight of removing that number.
Got
and
it,
so then all of this extra buffer will happen, and then on finalize will come in and do that action.
Makes sense.
Right? So just this is how you do safety. You have any comments on this? No? Do you? Yeah, please, of course.
Yeah, if you remember your frameless assignment, we had this hooks on initialize, on finalize. An important thing to remember is that both are used to handle some system task. Nothing related to your extrinsic, something that is system task. So what you do something on initialize. What did you used to do? You used to clear the headers key or something and then add extrinsics and apply extrinsic, right? And on finalize is kind of extension of that. So what you do at the beginning and you clear something or you do something, it's if you think about it, it's the same thing. It's like everything in between is encapsulated by on initialize and on finalize, right? So what you do on initialize, you say, my system functions will take this much weight, right? And it includes the clearing task as well. And that weight now is used to calculate how much time or how much weight you have left for doing some other task, like extrinsic, like some other ad hoc task you need to do. So this is why this weight is pretty important. So you keep track of how much more things you can do in a block. Does that make sense?
Okay. Again, and we'll go over these ideas again as well when we go to actually benchmarking and weights, okay? Yeah. Okay, so on finalize. In general, you should avoid using it unless you really need something to happen at the end of the block. You should generally avoid using it, especially any complex logic really shouldn't exist in on finalize. Instead of using on finalize, where you're saying, I want this thing to happen at the end of the block, perhaps you should consider doing it at the beginning of block n+1. Again, on initialize, because it happens at the beginning of a block, it has all of the space available to do an execution, and then we might not include any transaction if it's too full. On finalize, it happens at the end of the block, so if it needs to do a lot of work, then we're overfilling a block, that's bad, right? So you might consider moving logic from on finalize to on initialize. It's just context, right? And again, if you're using on finalize, very discrete, very simple, very well understood logic that's accounted for at the beginning, okay? Okay, hooks, poll. Poll is something new. I think it's still in development, so I don't think it's actually, you can use it yet. But it's a non-mandatory version of on-initialize. It's in the making. The whole idea is that, as I told you, on-initialize must happen. A block is invalid unless it doesn't happen. We found in general that on-initialize, on-finalize, it being mandatory hooks, this has been a little bit of a foot gun, a little bit of a kind of very tight requirement. Instead, we're preferring things like poll, and I'll show you later on idle, which have the same timeline in the hooks, but happen more, they can handle if they don't succeed or if they don't finish, right? It's kind of more relaxed. And then again, I talk on idle. On idle is another optional variant of on finalize. It's also executed at the end of the block, but basically, it runs as much as it can. It doesn't guarantee that it runs everything. It just tries to run as much as possible. And one other small difference is that it only executes one pallet's hook per block randomly. So the idea is that, let's imagine you had some like long-term cleanup task, right? You could, but the cleanup task, it doesn't have to happen right now. It can just happen with any extra block space, right? You could actually make an on-idle hook, which, hey, if the block is mostly empty, just use the block space to do these operations that are good for the system. And if you can't finish, no problem. If those kinds of tasks are in mind for you, on idle is perfect. Let me think of an example on idle. You could use on idle, for example, to do staking rewards. So you know there's a bunch of users who earned a reward. It's very expensive to submit all rewards in one block. It's like thousands of users, hundreds of thousands of users, right? What you could do is keep track of all the rewards and have an on-idle hook that every block, however many we can transfer, we'll transfer. If it's full, then we won't transfer any. And if you're a user who wants your staking rewards now, you call it now, right? But again, this is one option of doing it. My preference in terms of how to design APIs like this is to have the user initiate the call, right? There's no reason that the blockchain has to be doing this extra work for the user. Usually, knowing what to do with on idle itself requires logic and computation, right? So, but it's an option available to you. So again, in the future, we're moving away from mandatory hooks. We want to turn all the on-initialize to poll, all the on-finalize to idle, and we want to basically create new primitives inside a frame system where if you really need a mandatory hook, you can do it, but it's not the default option for Pallet developers. There's a way to do it, but it's not the default design decision for a Pallet developer. And this is again because on-initialize, on-finalize, because it's required and mandatory, it's a little bit of a foot gun. It's a little bit not, you know, easy to use. Okay. So recap. This is a nice, you can reference this in your slides. This is a nice little diagram of where the hooks are being executed during a block. Okay, in what order? Okay, so now we're looking at the kind of off-chain hooks. The first one we'll look at is Genesis build. So this is a function you can access inside of your pallet, and it will only execute at the genesis of your blockchain on block 0, right? So the various ideas for genesis build, and you might use this in your own pallet tests. There's a genesis build for pallet balances, which gives everyone the initial balances at the beginning of the block. There's a genesis build for the staking pallets, or at least the consensus pallets, which decides who are the initial validators of the blockchain, right? You need that information in the block 0. There's a genesis build for treasury. I think treasury, it seeds itself with some balance. So if you looked at treasury pallet, I think you'll see a genesis build where it gives itself existential deposit balance, so because it's an account, right? Things like that. So if you're building a multi-token treasury, maybe you want to do a genesis build where at the beginning of the block it gives itself some money so that it can hold tokens, right? Did you solve the question? No? Okay. So a hook for you. And there's great examples of genesis builds. We might go, you go over that, right? Genesis builds or no? No, if we don't. There's examples within the pallets, okay? Yeah. This is the same thing. Oh yeah, we're showing some stuff here actually. Yeah, Genesis build. So you can see here's an example of a basic Genesis build. You create a struct with some fields. This is the things you want to populate. This isn't necessarily have to be one-to-one to your storage. This is just whatever data your Genesis build needs, it passes through these fields, okay? Then you have some default for Genesis. So obviously you want to have a default state for your Genesis. Like, you know, in the case that someone doesn't provide any data for you, what should the Genesis state of your blockchain be? And then inside of your pallet, you can include this block, Genesis build for Genesis config, which has this pallet Genesis build macro. And there's a function called build, and you can run whatever logic you want accessing these fields. So you can imagine, for example, if I want to create Genesis build, let's just look at it, right? For the balances palette, right? Let's just look. Okay. Substrate, frame, docs, frame, balances, lib. In here, palette, Genesis, build. So you can see the exact same thing. So here, the Genesis config, it only requires a vector of a tuple of account and balance. Obviously, this is not the structure that's in the blockchain, right? It's a map. But I don't need to map the structure. I just need the data. The raw data I need is just a vector, an arbitrary size vector of accounts and what their balance is, right? And the default Genesis for a blockchain, if you don't specify anything, is empty. No accounts have any balance. And then the Genesis build logic itself is a function which accesses that vector. And you can see it does this thing. It basically goes through the balances. It iterates over all of them. It calculates the sum. It sets the total issuance to that value. And then it goes over to each account. Where's the deposit? It asserts, this is good. So you could actually panic in the Genesis build, right? So you can panic so that when you build your blockchain, if something's wrong, it will not build the blockchain. Here we're ensuring that every user's balance is at least equal to or greater than the existential deposit, right? So if I have a Genesis build where it's not enough balance on a user, we panic. We don't even let you make the blockchain. But somewhere, am I crazy? Oh, account store insert. Yeah, accounts here, I guess this is a little bit like a low-level API. We're storing into the account directly their free balance. So now all the users have this amount, right? So again, it's very kind of like, you know, very low level, right? Like you get some data, you just shove it in on the beginning of the block. But the idea of the hook is that the hook runs one time at the beginning of your blockchain. Okay? Yes. Comment. Cube. The cube is here.
So is this basically where we would create like a root account or something like that?
No. So root does. All right. Well, so root does not need an account. Root is root.
Not sudo.
So
like
what's your project? What do you want to do?
the DEX.
The DEX. So
The DEX account, for example.
the DEX account is not generated here. The DEX account is an address, which there's a function which generates the address, right? So if you want to give your DEX account some tokens at the beginning of your blockchain, you do that here. But you don't need to generate the account. The account is like a bytes. Like you have a function which runs and it gives you bytes.
Yes.
Okay. Okay. Back to the presentation. Yeah. So and then the Genesis config is another aggregate thing built at the runtime level, right? So the runtime aggregates all of the Genesis builds, and you basically expose this struct runtime Genesis config with all the things. I mean, this is exactly the aggregate runtime stuff we talked about, right? But Genesis build as well.
Yeah, Shawn. I think also in terms of hooks, we kind of left one hook. It's called, I think so, for Kian introduced it, and it's kind of like asserting. Let's say the name of it. It kind of does like assertion at the end of the block actually.
Assertion at the end of the block.
Yeah, it's called.
I mean, all the hooks we have are here. So there's integrity test, tri-state.
Yes, integrity test.
So yeah, I haven't got to it yet.
Yeah.
Okay. So Genesis build. Okay, so that's Genesis build. Yeah, another thing is that recent changes move Genesis build to be used in the runtime, so we don't need to have any STD features. It used to be that Genesis builds happened with STD. We don't need that anymore. So that's going to be better for everyone. Okay, off-chain worker stuff. I don't really want to talk too much about it. Yeah. Let's see. Okay, so I mean, at a high level, the off-chain worker is a hook. You can provide in your palette some hooks to the off-chain worker. The off-chain worker, again, is some kind of sidecar application running alongside your runtime, right? And again, here, you can read chain state via RPC. You can submit desired side effects back to the chain as transactions. The code lives on chain. It's upgradable with your runtime. Why is it down? Why is that a thumbs? That's a thumbs up, right? Oh, it's upgraded only in synchrony. So I guess, okay. Well, I think this is cool. The code lives on chain. When you upgrade your runtime, you can also push upgrades to the off-chain worker. I think that's cool. That's thumbs up for me. It's ergonomic and fast state access. State rights are ignored.
Maybe means that like you need to upgrade the runtime if you want to upgrade the sidecar.
Yeah,
But,
I agree.
But sometimes maybe you just want to upgrade the sidecar,
So-
even more likely.
I think it's a thumbs up and thumbs down. It's a curse and a blessing, right? You can submit transactions back to the chain, but it's a source of many confusion. Again, the most common thing I hear is, can I do this with off-chain worker? And I'm talking to someone who, at the moment, forgot everything they know about blockchains, right? I hope that you will remember what blockchains can do in general and know that off-chain workers are not magical. It's just implementing an application alongside your runtime. Okay? Here's the hooks. Okay, yeah, there's some stuff here. Up to the client. Yeah, so another thing. Even though you put an off-chain worker in your code, the nodes running your blockchain don't have to run the off-chain worker. They can turn it off. I think by default it's on, but it's not required to run the off-chain worker. So if you're depending on your node network to do something for you, they can all choose to turn it off. And that's your problem. Okay?
So what could be a good use case for it then?
Oh, we have one. We use off-chain workers for staking. So the staking system, to calculate the fragment election, which is the NPOS system, is very, very heavy in computation. Okay? So we rely on off-chain workers to be able to do that heavy computation asynchronously, best effort, it's not mandatory, and to calculate the best possible outcome. And then when the user feels they have a good outcome, they can then submit it to the chain and earn a reward. But we just basically, we are packaging with the runtime a application which can make this better. And then it actually, we can, obviously, making a proof is hard, verifying the proof is easy. So we have the verification process on the blockchain. And then finally, we have a fallback system. So if no one provides for us a proof, because off-chain worker is totally optional, it could be that no one runs it, we then fall back and run the process ourselves. We try to avoid doing it if we can. This is a good use case. Again, everything about that process is totally reasonable, totally verifiable, totally consensus driven, and is kind of optional, right? More off-chain worker stuff. Special host function. They have execution limits. You know, it's a powerful tool. Again, something that, you know, maybe has a use case. Okay, integrity tests. This last thing, right? So integrity tests is a set of tests that come from your pallet, but then put into the construct runtime. So basically, you can have some knowledge about your pallet that some things have to be a certain way, and that you can tell the runtime, if it isn't configured this way, error. For example, we just showed how you can configure, what are they, do they have examples here? We just showed how you can use a configuration in the runtime to control the maximum length of a vector, right? We showed briefly how you can do that, right? You could make it so that an integrity test inside of your pallet ensures the vector size is never 0, and the vector size is never greater than 1,000, right? So even though you give full freedom for the developer to write whatever number they want there, during compilation time, we can detect through the integrity test that the numbers are something that makes sense for what you expect people to use your pallet for, right? Does that make sense? Like, we try to prevent foot guns. So I'm adding your pallet. Oh, maximum number of users? Oh, put 1 million. No, no, no. Our pallet does not have in mind 1 million users. This is a different level of complexity. We cause an error. Does that make sense? So here, this is exactly this thing. There's an integrity test. You can make this function inside of your pallet. You can put assert statements, panics, and you can assert that the config of that pallet, like for example, here is the number, is greater than 0, right? And if in the runtime, if this assertion is not satisfied, your code won't compile. Or your code will compile, but when you run the test will fail, right? So if you do cargo test runtime, it will fail. Of course, it will still compile. Okay? Tri-state. This is a means for you to ensure the correctness of your STF after each transition. Entirely off-chain, custom. Oh, yes, 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 yes. So tri-state is a hook that runs kind of parallel to your chain, right? Completely parallel, which is constantly just kind of looking at your chain, making sure nothing is really fucked up. Right? That's the basic idea. Imagine, for example, you can make a tri-state which ensures that the total sum of all balances is equal to total issuance, right? If ever that got out of sync, that would be bad. You define that logic in your runtime, in your pallet, because it's specific logic for your pallet. But this is executed not on chain, it's executed on the side, right? And it's executed lazily, right? So there's, you know, like this thing can be very expensive or very whatever. It's happening not in the runtime, it's happening on the side, but of course it's defined in your pallet because usually it contextually needs information from your pallet, right? So you can be designing your own pallet where it's like, hey, make sure that these conditions are always being in sync. Yeah, question.
Is it like being paranoid or something? Like we are checking a lot of states.
Paranoid?
Inside. Yeah.
How many $1 billion are these things worth?
Yes, I'm saying.
Are we even close to paranoid enough?
No, I'm saying like we have in the validation after dispatch, everything we have testing state to everything, right? And then we have another hook running parallel, checking state again, like
yeah.
if it's correct.
I can feel from my feeling in the space is that this is not even enough. We are not even close to the levels of auditing and assurances we have on these systems. These systems, when your state machine goes wrong, that all hell breaks loose. How many contracts have been hacked? How many dollars have been lost? We are still in the wild, wild west. I don't think we even have near enough. But again, what's important is that none of these tools are mandatory. These are all different tools which are exposed to you that you can use for your needs, right? Okay. By the way, are there examples from your assignments about this? Maybe the tests? Okay. Well, I guess I feel like Kian will be very disappointed that you don't have a good answer for that. So, and here's again a recap of the hooks when they get executed. Okay, and then again, I would recommend you go through this yourself. Like, you know, I'm talking on my own experiences. Keon has here his own notes. But yeah, you can get, you know, that experience on your own. Any questions about hooks? Did it land? Generally makes sense. There are these things available to you. They're mostly optional, right? But they're very cool.